So the binomials, we talked about expanding out. The other thing, of course, which is just as important, is the factorising back in. Certainly when we're trying to solve equations and things like that. The number of terms that an expression has usually gives us a clue to the technique to try. Mind you, before you do anything else, always look for the common factor. Does it have a common factor you can pull out first? That's going to make life a lot easier if you find it. Now, if it's only got two terms, and it's not a common factor, pretty much narrows it down what it can be. So it's probably going to be difference of two squares, maybe. It might also be the sum or difference of two cubes, which we'll talk a bit more about later. If it's got three terms, trinomial. And the most common type of trinomial we see is a quadratic. So we're looking for those sorts of things. Is it a quadratic trinomial? And if it is, hopefully the coefficient of x squared is 1, makes life easier. If it's not, then we might try splitting the middle and things like that. 4 terms. All right, now I've got 4 terms. Well, we try and turn it into a different question by grouping in pairs. So we'll just factorise 2 of them at a time and hopefully we'll produce a common factor. That's the idea anyway. So, let's do an example of common factor. This will be tricky. Well, all factorising is dividing by the common factor. Sometimes people go, oh look, I've pulled it out. Oh, hang on, how do I know what's left inside? So if you're ever unsure, just divide the term by whatever you've taken it out. I mean, because that at the end of the day is what you've done. I wonder what they've got in common. Okay, obviously it's next. Not an example there to blow your mind, but just as an example of common factor, of course. This one I put up there just to highlight, look for all the common factors. I mean, the common mistake would be people just pull out the 5 or they just pull out the x. But no, we need both of them pulled out, the 5 and the x. Common factor, hang on, 4 terms, we said that was grouping in pairs. Well, you'll notice all 4, no, there's not a common factor there. You sort of look at it and go, oh yes, look at that, x and an x and a, oh damn. Oh, but hang on, look, M and an M and a, oh, damn. Oh, it's all right, N and an N and a, oh, damn. Oh, look, Y and a, oh, damn. We can't do anything that's in all 4. So we just pick a pair. It doesn't have to be the first 2 and the second 2, although a lot of times that works. And it's probably what I'm going to try here. If that doesn't work, pick a different pair, see what happens. So in this case, the X comes out, the y, but you'll notice I've pulled out the negative y rather than the positive y, because the idea is the other factor we want to make the same, because then we can go, oh look, common factor, and we can finish it. So had I just taken out plus y, I would have had negative m plus n, which is not the same. So we want to try and make that other factor the same. Now that it is, I can say u-but. That's an important part of the solution, going u-but. We've got m minus n and then x minus y. Difference of 2 squares. So a reminder, we talked about the expansion. Well, obviously the factorising is going back the other way. 16x squared minus 1. Well, bingo. Again, we know the pattern. We don't have to waste time. I can write the first one as something squared, 4x all squared. I can write the second one as something all squared. Bang, we get straight to the answer. Oh, hang on a sec. 3 is a difference of 2 squares. 3 is not a perfect square. 75 is not a perfect square. This is an example with, hang on, look for the common factor first. 3 goes into both of these. When we pull the 3 out, then it becomes obvious the difference of 2 squares. So y minus 5, y plus 5. Ooh, 4 terms. Ooh, it's still grouping in pairs. Might not immediately be obvious, but the first 2 I can pull out a common factor of 5. The second 2 is a difference of 2 squares. I still have 2 terms now where it has a common factor of x minus y. So it does work. So we get left with x minus y in the first one, and the second one is 5 plus x plus y. So there's actually 3 terms in the second one. All right, let's talk about quadratics. So the Monic quadratic, which is of course the easier of all them. If you think about expanding out the quadratic, that's what we would end up with, x squared plus a plus bx plus ab. And that's why the idea has always been, oh, well, look at the numbers. What multiplies together to give last number, what adds together to give the middle number. If we can work out those two numbers, we can go back to what it started from. 18, multiply 18, add together to give 9. Now, if it's a positive number that it's multiplying together, then they must have the same sign. It's either going to be two negatives or two positives. I look at the middle term, that's a positive, so I know I'm dealing with two positives there. Well, 6 and 3, isn't it? So there we go. Multiplies together to give 18, adds together to give 9, 6 and 3. Now this time, they multiply together to give a positive number, but add to give a negative. But again, if they multiply together to give a positive, the signs must be the same. So this time I'm talking about two negative numbers. Well, 3, thank goodness, 3 is a prime number, so it doesn't give me a lot of choices, really. It must be 3 and 1. And that does work because negative 3 and negative 1 would make negative 4, so it does work. So t minus 3, t minus 1. Uh-oh. There's y's in there, making it a bit tricky. Doesn't matter. Again, it's the coefficient that's important. It's the numbers that we're playing with. Don't worry about the y, it'll sort itself out later. So we're saying multiply together to give, technically we're saying 4y squared. And add together to give minus 5y. But we don't have to worry about the y's, because each term's going to have something y. So when we multiply it together, we will end up with something y squared. That's not the issue. It's the number is the issue. 5 is what they're going to add together, so you've got to be 4 and 1. So instead of writing x minus 1, we write x minus y, and instead of writing x minus 4, we write x minus 4y. Okay, splitting the middle. 3x squared plus 4x minus 7. You've probably seen different ways of doing this. How many people are used to using the cross method? That's a rather common way of doing it. People with cross method. Personally, I prefer this one. I'll show you why. Because it still goes with that idea of what multiplies together to give, what adds together to give. I'm going to multiply the constant by the coefficient of x squared. I'm going to say what multiplies together to give negative 21. So not negative 7, but negative 21. And what adds together to give 4. It's negative, so I know it must be a positive times a negative in this case. Now I notice it adds together to give a positive, so therefore the positive number must be the bigger number, because I'm going to add this positive and negative number together and end up with a positive number. So 21, it also means the difference between these two numbers is going to be 4, doesn't it? Gosh, if only I knew two numbers differ by 4, what could it be? They multiply together to give negative 24, but when we add them together we get positive 4. Oh, what about 7 and negative 3? And then we split the middle. So we're doing exactly what it says. We split the middle term into those, and it becomes a grouping in pairs question. So now the first two, I say, oh yeah, 3x is a common factor. Second two, 7 is a common factor. Bang, got the answer. So it keeps the idea of things we already know. I don't need to learn a new method, this cross method or whichever method you're used to using, what have you. So that's why I like this one. Let's try another one. 2x squared minus 5x minus 12. So instead of saying what multiplies together to give negative 12, I'm going to say negative 24. Adds together to give negative 5. So in this case, the negative number is going to be the big one. 24. Oh, geez, that's got lots of factors, isn't it? 8 and 3, it would have to be, wouldn't it? So negative 8, positive 3, grouping in pairs, and we have our answer there. All right. It's enough of me speaking today, isn't it?